In this video, I'll be going over the architecture of the ClipStash project. So we'll be creating an enterprise-grade architecture that consists of multiple components and layers. We have a single web API combination server with a web component, a service layer, and a data layer. We also have a domain component which can access the web, service, and data layer at will. We'll be going into details over these different layers and components shortly. Clients can interact with the server either through using their web browser or through an API command line client that we'll be building. These clients only ever interact with the web component, and the web component can access data through the service component. So data will flow from the web through the service into the data layer. The data will then come back through the service layer into the web component. Then finally, it can be returned either to a browser or an API client. The web component is responsible for communicating with the outside world. It reports errors, it renders pages, and it provides an API. It manages application state, including establishing database connections, binding ports, and spawning background tasks. As mentioned previously, the web component can only interact with the service layer and with clients. It has no access to this data layer. Next, we have the service layer. The service layer acts as an intermediate layer between web requests and the database. The purpose of this layer is to abstract between user requests and data access. And this also allows us to insert application logic within this layer. Doing so will apply this logic to all clients that are accessing the system. The service layer here is able to communicate with both the data layer and the web component. However, it cannot communicate with clients. So it's limited to communication within the server itself only. Next, we have the data layer. The data layer manages data storage and retrieval, and it works directly with the database. The data layer contains no logic outside of whatever logic is present in database queries. All the incoming data to the data layer is unmodified, and all the outgoing data is unmodified as well. The data layer is responsible for maintaining internal consistency when applicable. The data layer is only able to access the service layer. It cannot access the web server and is also unable to access any clients directly. The data layer only moves data into the database and out of the database. So it doesn't modify anything. So all the data is unmodified. It's just transformed in a way that can be stored in the database, and then it again is transformed in a way that is readable by the program. If we include any logic in this layer, there's the possibility of introducing bugs in our program, because this layer might accidentally make a change to some data when it's either coming or going. So you want to make sure that the data is unmodified in all cases. The last thing we have is the domain. So the domain is simply data types that are shared with all layers and components. The domain portion of the project is what enforces business rules on data. We'll actually be utilizing Rust language features to force the compiler to ensure that all of our business rules pass. Since Rust will be enforcing the business rules on these domain objects, it's safe to access them from the web server, the service layer, and from the data layer. These slides are available in the project directory if you need to reference this information later, and it might come in handy when you're working on the program. Now that we've seen a high-level overview of the ClipStash project, we're ready to start coding.